A force of 2.3 newtons pushes on a door at a distance of 60 centimeters from the hinge of the door. What torque acts on the door if the force acts perpendicular to the plane of the door? So, in this case, we have a door with a hinge and a doorknob. We're pushing on the door at a distance of 60 centimeters from the hinge, and we're pushing straight down, right, perpendicular to the door. So if the hinge is our pivot, then we should be able to answer this pretty easily with what we know of torque, right? The first equation that we learned for torque is simply force times distance, right? So multiplying the force by the distance from the hinge, we end up with an answer of 2.3 newtons times 60 centimeters, that is 0.60 meters, which gives us an answer of 1.38 Newton meters. How about if the force acts at 45 degrees to the plane of the door? So instead of pushing the door straight on, we're sort of pushing it sideways, right? Well, the sideways part of the force isn't actually going to do anything to the door, right? We can't shift the door away from or towards the hinges. So the only part of the force that we're going to pay attention to is the amount of the force that is perpendicular to the door, right? Remember that we can represent forces as the sum of vectors. In this case, we can represent it as the sum of a vector that's perpendicular to the door and a sum of a vector that's parallel to the door, and we can ignore the parallel component. So, find the component of the force perpendicular to the door. How would we do this? Well, it's not too hard really. It'll just be force times distance times the sine of 45 degrees, right? Because that will be the shorter edge of a triangle. If we have a force acting on the door at 45 degrees to the door, then it will be the sum of these two components, right? With this angle being 45 degrees. So, if we wanted to find the length of one of the shorter sides, it would simply be the long side times the sine of 45 degrees, or the cosine of 45 degrees. And that will tell us the amount of force that is acting perpendicular to the door, which is exactly what we want to know. So, multiplying that together gives us an answer of 0.976 Newton meters. So we can see that by pushing sort of diagonally on the door, instead of straight onto the door, we end up with less torque on the door. We don't have as much turning moment acting on it. In fact, if we were to push completely parallel to the door, we wouldn't get any torque, because we'd simply be pushing the edge of the door toward its hinges or away from its hinges, which wouldn't really get anywhere toward opening the door.